Hello guys, here is here one more solving video I've been cam on the LeetCode Cam channel. So in today's video, we are solving our question number 606 by the name of construct the string from binary tree. So yeah, in today's video we are solving this question, and by the way, this is a medium one question which we are solving in the Python 3. And in today's video the question is little bit bigger, but anyways we will solve it. And in this question there are only two examples with the diagrams, and let me tell you the topics. There is only four topics: string, tree, depth first search, and binary tree. So yeah, we are solving this question without taking any time. So let's move to computer screen and let's do a coding with laughing. Guys, by the way, now let's start with today's video. And like I have told you in my introduction, we are solving a question number 606 by the name of construct the string from binary tree. So now let's start our today's video and let's start to solve this question anyways. So first of all, we understood the question. What is the question is trying to say to us? Then we'll start to solve it in our LeetCode website. So now it having given me a root of a node of a binary tree. Our task is to create a string representation of the tree following a specific set of formatting rules. The representation should be based on pre-ordered reversal of the binary tree and must adhere to the following guidelines. First, node representation. Each node in the tree should be represented by its integer value. Number 2, parentheses for children. If a node has at least one child at the left or right, its children should be represented inside parentheses specifically. Number 1. If a node has a left child and the value of the left child should be enclosed in parentheses immediately following the node values. This point are in a parentheses for children. Okay. Number 2 point. If a node has a right child, the value of the right child should also be enclosed in parentheses. The parentheses for the right child should be those of the left child. Now, third, omitting empty parentheses. Any empty parentheses pairs, for example, should be omitted from the final string representation of the tree, with one specific exception. When a node has a right child but no left child, in such cases, you must include an empty pair of parentheses to indicate the absence of the left child. This ensures that the one-to-one mapping between the string representation and the original binary tree structure is maintained. In summary, empty parentheses pairs should be omitted when a node has only a left child or no children. However, when a node has a right child but no left child, an empty pair of parentheses must be precede the representation of the right child to reflect the tree's structure accurately. Okay, now let's see our case 1 and case 2. In the case 1, here he created one diagram of like it is looking like a one tree, okay, binary tree, in which here in the first circle here he wrote in down 1, okay. Let me give him the weight, and then if you see the second here he wrote in down 2, and in 2 is going on to the 4 is the last, and then it is coming on to the 3. If you see the here root binary tree, okay, here he wrote in down 1 2 3 4, and the output I'm coming 1, then parenthesis 2, then parenthesis 4, then in the parenthesis 3. Why? Because originally it needs to be 1 parenthesis 2 parenthesis 4 parenthesis, and then parenthesis 3 parenthesis, but you need to omit all the empty parenthesis pairs. It will be 1 parenthesis 2 parenthesis 4 in sorry 1, then inside the parenthesis there is 2, then inside the parenthesis here he created one more parenthesis in which he wrote it down 4, and then here he created a one more parenthesis in which he wrote it down 3. So that is why this output is coming. If we see the second diagram, here he created one root binary tree in which he wrote it down 1. Let me paste it 1, and then 1 it is going on to the 2, then it is going on to the 3, and then it is going on to the 4. Okay, and then here he written down in the root 1 2 3 null 4, and the output is 1 rounded brackets 2 rounded brackets, then in the rounded brackets 4, then rounded brackets 3. Why this output has been coming? Because almost the same as the first example, except the parenthesis after 2 is necessary to indicate the absence of a left child for 2 and the presence of the right child. Constraint, these are the constraints it has been given me. So I hope you enjoyed it. Now let's try to solve this question in the LeetCode Camp website. So let's come on it here, and total, let me show you, total 4,86,000 people has submitted it, only 3,41,000 has been accepted. So we have solved this question in the Python 3 by the way, so let's try to solve it. So first of all, we define a class of a solution because it is a rule of a LeetCode Camp. Whenever we want to start to solve any question, so first of all, we define a class of a solution. Def tree to str self comma root. Then if a statement root is none, return. Now first of all, our step 1 is we start with an empty result string. Okay, so write result equals to square bracket. Now we define step 2. In which we define perform pre-order traversal, and then here when we do this all the things, so we define a self comma pre-order traversal. Okay, and then here we define root comma result. Now we define step 3. Return the final result string. Return dot join result. And then when we do this all the things, so now what we gonna do now? Here we define def pre-order traversal self comma node comma result semicolon enter. And then when we do this all the things, so now we want to remove this. Yeah, you want to remove this. Define if node is none, define return. Now what we gonna do now when we do this all the things, so define here step 4. In the step 4 you want to write here semicolon and then define here append the current node and then value to the result. Define result dot append str node dot val. Okay, now when we do this all the things, so now here we define step 5 and check if the current node has a left child or a right child. When you do this all the thing, define if node dot left is not none or node dot right is not none. Enter. Define here step 6. Okay, and the step 6 is our, let me show you. You'd want to define here if there is a left child comma add empty parenthesis for it. Perfect. Define result dot append. Okay, define in the rounded bracket this. Okay, perfect. Now when you do this all the thing, now you only want to do it, remove it. Now perfect. Now enter press. So we come out of step 7. In the step 7 here we define if there is a right child comma process it similarly. Now perfect. So now when we do this all the things, so now let's see to run this code. So we have written about all the code. So when I run this code, so let's see the running code. So when I run this code, so now the running code has been accepted. In our case, when our expected output is this and my also output coming this. In the case the expected output is this and my also output has been coming same. Now last thing is to submit this code. So when I submit this code, so now the submission code is also be accepted and I beat 100% people. So now let me paste the solution beats 100%. Okay, now post it. So I hope you enjoyed today's video. In today's video, we solve a question number 606 by the name of construct strings from a binary tree. If you enjoyed today's video, so don't forget to like, share and subscribe and all the notification bell also for more these type of amazing videos. So now let me meet you in the next video and next very amazing video. So now for today, goodbye.